Hello everyone. Let us see another application of capillary electrophoresis for the analysis of some non-steroidal anti-inflammatory drugs, which we abbreviate it as NSAIDs. These NSAIDs generally contain a carboxylic acid group, and once they get ionized, they can behave as anions. So for our purpose, I am choosing 5 NSAIDs, and the buffer that has been chosen will contain glycine. Glycine is a very small molecule. It contains a carboxylic acid group, and it also contains an amine group which can be ionized at a particular given pH. It is about 9.1. So the drugs that are being chosen have been given here. The 5 NSAIDs are Sulindac, Indometacin or Indometacin, Piroxicam, Tiaprofenic acid, and Alclofenac. This is not Alclofenac, this is Alclofenac. Alclofenac is aceclofenac, which is another version of diclofenac. This one is Alclofenac, which is a much smaller molecule when compared to aceclofenac. So here we said that within the buffer we are using glycine, but along with that glycine an additive is also taken, which is a triethanol amine. So in the presence of glycine and triethanol amine, these compounds are being separated. So I am just showing the structures of these 5 NSAIDs. This is the structure of Sulindac, Indometacin, Piroxicam, Tiaprofenic acid, and Alclofenac. Right. So all these structures, they almost look similar when it comes to the first, second, third, and fourth. But one important thing to be mentioned is, once they get ionized, since all of them almost contain a carboxylic acid, so the charge is almost the same. Therefore, for the separation, it is not the charge that is becoming more important, but it is their sizes that become more important. Sizes, or we put it in another way, their molecular weight. So if at all we look at the molecular weight, from Indometacin till Alclofenac, the molecular weight is being dropped from about 357.8, it is dropping to 226.6. Sulindac and Indometacin, they are very much closer. Let us look at their separation. Here I am showing the electrophoregram. Within this electrophoregram, absorbance versus time has been taken, electro-osmotic flow, and the compounds that are being separated according to their rate of migrations. For remembrance purpose, you just remember it as SIPTA, SIPTA. The first one eluted being the Sulindac. I refer to Indometacin, Piroxicam, Tiaprofenic acid, and Alclofenac. So previously I said that triethanol amine is added. This is added because it is one of the best cationic components, and since it is one of the best cationic components, it can reduce the electro-osmotic flow because of its relatively low ion mobility, and it will also increase the viscosity of the running buffer. So this has a greater importance in the separation of these NSAIDs because it will increase the resolution of the components within the mixture that contain these NSAIDs. Right. So whatever NSAIDs that have been chosen, all these are fully charged at a pH of about 9.1. So as I said, how do we separate them? Separation is not just according to their charges, but it is according to the weights, molecular weights. So the smallest molecule will migrate at a slower rate. So out of all these things, the smallest one being the Alclofenac is migrating at a very, very slow rate. So if at all we understand why this is migrating at a very slow rate, let us understand about the theory of the capillary electrophoresis, which have been discussed in our last videos. All these are behaving as anions, and the natural behavior of the anion is to get attracted towards the anode. But within the capillary electrophoresis, the electro-osmotic flow and the ion mobilities must be towards the cathodic part. So the electro-osmotic flow, which has a greater magnitude, it will move towards the cathode end, supposing that here is a cathode end, and this will try to force all the ions that are present within the system, within the analyte system, towards the cathodic end. So since the Alclofenac, which is the smallest one, its natural ability is to move towards the anode, this has to be pulled towards cathode, and this takes a longer time for the electro-osmotic flow to pull towards the cathode, and hence it will be eluted in the end. There is data that has been given in one of the journals I have cited here. It is a Electrophoresis journal in 1999, where the effective mobilities have been compared. This is the electrophoretic mobilities of the given ions. Two systems have been chosen. One is the aqueous system and the another one is a non-aqueous system. We will consider only the aqueous system. Within the aqueous system, we can see that the electrophoretic mobilities are being dropped. If at all we also consider the non-aqueous system, the trend is irregular when it compared with the aqueous system. Within the aqueous system, the last NSAID to be eluted is Alclofenac, but in the case of non-aqueous system, we can see that the least mobility is with the Piroxicam. So this is how some of the NSAIDs can be separated with the help of capillary electrophoresis, and this capillary electrophoresis is taking a big leap in the field of technology, and it is also giving a good application for the pharmaceutical chemistry. Thank you.